Hello, my name is Gunby. I'm the Executive Director of Fidra, and I'm going to talk you through a few thoughts on chemicals, the circular economy, and an environmental perspective. Environmental charity, we're based in Scotland. We work on discrete demonstrator projects that seek to address environmental threats from pollution to habitat degradation. We work in particular on plastic pollution such as pellet loss and chemical pollution such as PFAS, or forever chemicals as they're known. And we also look at chemicals of concern in sewage sludge such as microplastics, PFAS and pharmaceuticals. And we've also worked on chemical groups such as bisphenols, and we look at flame retardants in furniture. Today I just wanted to highlight the issue of chemical use and management in relation to the circular economy. So chemicals play an important part in our daily modern life. However, the downside is that chemicals also create chemical pollution. Chemical pollution is a key driver of biodiversity loss, a contributor to the climate and health crisis, and it also creates a barrier to a safe circular economy. According to the Stockholm Convention, or the Stockholm Research Centre, I should say, there has been a 50-fold increase in the production of chemicals since 1950, and this is projected to triple again by 2050. This is not a problem that is going away soon. PFAS has been found in otters, it's been found in drinking water and human blood. It was recently suggested that Jersey residents who have been infected with high amounts of PFAS due to contamination of their potable drinking water, that they consider medical actions such as bloodletting. This is because PFAS builds up and bioaccumulates in the environment and in our bodies. It can take over 1,000 years for some PFAS to degrade. Flame retardants have been found in gannets and their eggshells in Scotland. And we know that bisphenols are extremely mobile. They're found almost everywhere. These are issues which are affecting the natural world and damaging ecosystems. Harmful chemicals such as PFAS, flame retardants and bisphenols are linked to serious health conditions such as cancer, fertility issues, neurological issues, autoimmune problems, learning difficulties, and so on. And the cost of cleaning up PFAS and pollution alone in the UK has been estimated at 9.9 billion per year if emissions remain uncontrolled. The cost and lost resources to the circular economy have not yet been calculated. We look briefly at how chemicals get into the environment. They can enter the environment via a number of routes, for example, through production and manufacturing sites. We have seen a case recently in Bentham in Yorkshire where residents were exposed to PFAS from a firefighting foam manufacturing site, for example. You can get contamination in the environment through direct use, product use, so for example through ski waxes. PFAS can be transmitted to the environment. When we look at wash-off, we can look at cosmetics or shower gels, shampoos or cleaning fluids that go through our water system. Microplastics from washing machine entering our wastewater systems, or pharmaceuticals through our own human waste. So chemicals can leach into the environment from landfill sites as well, and we have seen PCBs, which are chemicals that have been banned for many years, and they can come from landfill sites contaminating ecosystems. There's also a danger from everyday items contaminating recycling loops and the circular economy. So if we look at the circular economy, we know we need to transition from the linear model of production and consumption to a circular economy. It's never been more urgent. This also means transforming our chemical use and chemical management in a linear economy. In a linear economy, products are designed with one use in mind. We know what that is, who's likely to use it, how they're likely to use it, and when the product is no longer needed, it's disposed of. It's simple, but completely inefficient and unsustainable. In a circular economy, we aim to use less and keep products, materials and resources going round and round as long as physically possible. Sometimes that means simply repairing and reusing a product. So for example, when that wheel falls off our wheelie case, we just replace the wheel rather than the whole case. Or it could mean stripping it down to various components and remanufacturing them into something completely new. That means products that previously had a short lifespan will be lasting a lot longer. All this sounds wonderful, and it should be. But the key question is, where are the chemicals in all of this? One of the many challenges with chemicals is we do not know where they are in the supply chain. We often don't know which products contain harmful chemicals. It is worth noting that in 2019, the EU considered 75% of chemicals produced to be hazardous to human health and or the environment. Many manufacturers are importing products without knowing what chemicals are in their products, and this lack of transparency creates a huge headache for the safe circular economy. Chemical regulation is set to look at the use of a particular chemical and approve it on the basis of that use. The challenge with a circular economy is the product designer and manufacturer and the regulator don't know or can't predict who will use the product and what that product may become. So the plastic cable from your charger could find its way back to you as a recycled cooking utensil, or recycled plastic could find its way into newly moulded children's toys. This doesn't sound so bad until you realise that the plastic recycled cooking utensil could contain flame retardants, which are linked to cancer and fertility issues, and were never approved originally for food contact materials. And often recycled plastic contains higher concentrations of toxic chemicals, which could potentially be dangerous to infants. It's another reason why we know we can't recycle ourselves out of this mess and we need to reduce our consumption. But just to be clear, I'm not saying that we shouldn't recycle. I'm just saying that we must know where the chemicals are in order to repurpose and recycle safely. Chemical use and management of chemicals is creating a barrier to a safe and clean circular economy. For example, we're seeing valuable resources such as sewage sludge being contaminated with chemicals such as PFAS and microplastics, pharmaceuticals, and this is resulting in contamination of our soil. And just a couple of weeks ago, we did see Water UK come out and demand the UK government enforce better source control of PFAS, and they represent the water companies in England, Scotland and Wales. So we are seeing this as a growing problem, and many people in industry are recognising the challenges that this poses. Persistent and harmful chemicals are being added to all sorts of consumer products, including food packaging, receipts, school uniforms, other textiles and long-lived items. I have worked on PFAS and food packaging and have worked with supermarkets, and 8 out of 10 of the big supermarkets did commit to taking action to eliminate PFAS from their own brand food packaging. Countries such as France and Denmark have acted ahead of EU universal restriction on PFAS and already banned PFAS in food packaging. So we have found when we've worked on a number of these areas that whilst PFAS does perform a function, it is a non-essential use. And in order not to contaminate future resource streams, it really does need to be restricted. Bisphenols in receipts, for example, is an example where it took many years to ban BPA from receipts, only for it to be replaced by a chemical called BPS, which has similar properties and concerns, and around hormone disruption, for example. It's a clear case of regrettable substitution, where one chemical is substituted for another with similar harmful properties. It then takes many, many years to get that one removed. So a group restriction of chemicals is really important. When Fidra did a case study on school uniforms, we found PFAS was added to school uniforms to prevent it from staining. But on further investigation, after conducting surveys, we found that parents and carers were not washing school uniforms any less, or replacing them less frequently because it was stain resistant. In other words, it was completely avoidable use. So we really do need to see stronger source control and group restriction on the use of harmful chemicals. Long-lived items have particular issues in that chemicals we previously thought were safe may turn out not to be safe. This is what's happened with sofas. We have seen with the waste in domestic seating ruling that all sofas, for example, have to be incinerated due to their potential for containing legacy chemicals which are now banned under the Stockholm Convention. This is costing the taxpayer via local authorities literally millions. There's not paying for it, it is the taxpayers that are paying for this. And although there's very many valuable materials within these sofas, they cannot be safely dismantled and repurposed because we don't know which sofas contain those banned chemicals and which do. I would finally like to talk about some opportunities for policy. First of all, it's really important to say circular economy and chemical regulation cannot be developed in isolation. We really need to see quantifiable reduction in the use of harmful chemicals in everyday products and materials. Necessary use of chemicals wastes valuable resources, including resources that can be used in the circular economy. Ending unnecessary harmful chemical use will help to drive innovation in finding safe alternatives. Designing for the circular economy is not just about making a product more repairable, but also about the chemicals a product contains. We need to see better transparency and traceability. We need to know where these chemicals are in order to be able to reuse and repurpose products. Circular economy policies must consider piloting schemes such as product passports that are being introduced in the EU. They should ensure materials and their chemical content can be identified and tracked through their full life cycle, which may include multiple loops. Alongside better transparency and traceability, we need to see targeted investment into safe and sustainable by design, alongside green chemistry, to simplify and streamline products and processes. Current chemical legislation is rooted in a linear model and lacks a precautionary approach. We need better source control of chemicals, and we need to see chemical registration, authorization and regulation updated so it takes account of the circularity of goods and materials. It would be really important to see alignment with Europe on chemical regulation. It would be useful if we could have that commitment to alignment in the revised environmental improvement plan to match European chemical regulation. And this means that we'll be having the same protections as other EU nations. Currently, UK REACH has not restricted a single harmful chemical in the UK since leaving the EU. This means we are less protected from harmful chemicals now than European citizens and wildlife, and the gap is widening all the time. Alignment with the EU will help to ensure groups of chemicals are restricted together, which will prevent regrettable substitution and support a safe and clean circular economy.